Okay, so Sam Taggart here again. I am here with the simple serial kata. This is just a little something I threw together. It's intentionally ugly code. It's designed to mimic something that you might see from a grad student or some new LabVIEW user, maybe a technician who's just learning LabVIEW, and they're just trying to capture information from one instrument. And they're not really thinking like a software developer. They're just trying to get it done. And so I'm on the main branch of that. I'll throw a link in the comment or in the description. And I've opened up the project, and here's the front panel, right? So you specify resource name, you set an auto range, some manual range channels, and you run it. You press get data. It sends a command to the instrument, pulls it back, parses out the data, displays a waveform, and calculates the average, the standard deviation, and the variance. And then you can stop. Or you hit get data again, and it'll do the whole thing over again. So let's see what this block diagram looks like, and I'll warn you, it's kind of ugly. So, first of all, it's rather large. You got to scroll. We're initializing some stuff. Here we're opening a Visa ref. Here we're writing to it, so we're doing some formatting with the different values. Here we're reading some bytes. We're checking to see if there's an error or if we got a measurement back. If we got a measurement back, then we process that measurement string to populate the graph. Standard deviation average, we're calculating that. And then we also do some alarming over here. So this is doing some range checking and making sure the limit's high enough or something, or the average variance is high enough. And it's either red or green. And that's going to affect our plot color. That's it. It's really simple. The only other thing is this stop. So in a stop case, we're just closing the Visa ref and shutting down the loop. Very simple. Now, we've got a lot going on in this VI. So it may be very tempting to just hit block diagram cleanup, and that's fine. You could also run my blue auto formatter on here, and it would clean up a lot of this stuff. Blue doesn't do major rearranging, but it would do some things that would make it a little bit more readable. What I want to focus on here is creating SubVI and insert SubVI contents. These are the two simplest refactorings that we can do. And creating SubVI is great for big block diagrams like this because we can find a chunk of related logic and hide it away in a SubVI. And as we do that, then the structure of the whole program becomes a little clearer. The other thing that we're going to look at in a second is creating SubVIs like this can make it easier to test our code. So first, let's look at how it can just kind of simplify our block diagram. So we've got this code right here. And if we include the code that writes to the serial port, right, so we've got some code that takes in some parameters and sends a command to the serial port or a request. And this timer's in the way. Let me move that out of the way. Okay. So we highlight all the code that we want to be in our SubVI. And we hit create SubVI. And this is a fairly safe refactoring. It's not likely to break your code because when the create SubVI code that LabVIEW runs under the hood, we'll let you know if you do something crazy. Actually, as an example, let's just say I highlight this. So I've got some stuff that's inside the case structure and some stuff that's not. I'm pretty confident if I hit create SubVI, it's going to say, you can't do that. Right? So that's why I say that it's fairly safe. I'm sure there's probably still some edge cases where you can get yourself into trouble, but most of the time it's pretty safe. So create SubVI. Cool. So now I can go and I can give this a meaningful icon and a name, and I can set the icon to the name to get a quick text icon, add a description, and then I can hover over this. And right now it says untitled SubVI, but it'd say the name of the VI, and you'd see the description. It'd say, hey, it formats a string and sends a command to the serial device. That makes my code a little bit more readable. There's less going on there. I can look at this and see, oh, it's sending a serial command. If I want to know what the exact command is, I can dive down into here and see how it's getting formatted. Now, I specifically did not save this or add a description yet because I want to show you another feature. So that works. We could do that for this chunk of code right here. You know, right? Get the response, and it would spit out a string and 2 booleans when it says there's an instrument error or that got a measurement. And we could also do that here with some of this code. Highlight certain parts. We might have the part that pulls off the data separate from the part that does this calculation. Other interesting refactoring that we can do that's really simple and safe, which I didn't actually mention before, is proximity refactoring. So what we can do is just create some more space here and separate this and move this over here and this over here. And now we can see clearly this is one chunk of code of logic that takes the string and spits out the data for the graph. And this is another chunk of code that spits out these values. And maybe we even separate a little bit further and we put this over here. And then we see that what is this thing pulling off of? Okay, so we can pass in. So we could have one thing that passes all these on and does the alarm, or we could have a separate thing that does the alarm looking at just those 2 values. So we could separate those out even more and do a separate thing here. And keep this visible at the top level if that's what you want. There's a lot of options. I did say the reason I didn't say this is because I want to show you something else. So if we're thinking about testing, so create SubVI is great for extracting bits of logic so we can test them. In this case, we extracted the sending the serial command, right? So we just have auto range, manual range, and channel, and we send the command to read that channel. On some levels, that makes sense, but this thing kind of has too many responsibilities. So it's not only is it formatting the string, but it's also sending the string to the serial port. And maybe we decide that this SubVI shouldn't have all these responsibilities, so we want to separate those out. So what I'm going to do is insert SubVI contents. So this, actually I said insert, it's actually replace, sorry. Replace with SubVI contents. Make space in the calling diagram, so it's going to expand our diagram to make space so it fits. That's usually good because you don't want stuff getting hidden. Sometimes I click this, wrap the SubVI contents in a sequence structure so it's very clear what came from the SubVI and what didn't. But often I just end up immediately removing it, so I'm not going to do that right now, and I'm just going to do this. And it inserted a bunch of code, and what it inserted was actually this, so maybe it would have been nice to have that. But that's what it inserted. But now we can redraw this line, and we can say, okay, well, now we want to extract just that and not this serial thing. So we can do some proximity refactoring. This is getting kind of ugly, but this is what we want right here, and we can edit create SubVI. And now this is over here, and this is here. And actually, I am just going to hit block diagram cleanup because I'm tired of looking at this. There we go. Block diagram cleanup sometimes works, sometimes doesn't. In this case, it works okay. So here we have this. Now, the nice thing about this is it's what we would call a pure SubVI, and we'll talk more about that later. But basically, it only depends on the inputs and outputs. Every time you run it, it's going to give you the same answer. So whatever you set channel, auto range, and manual range to, every single time you run it, you're going to get the same string out. And so that makes it really easy to write a test for. Whereas the previous version of this SubVI where we had the serial read and write, or the serial write, well, that output depends on the serial port. If the serial port's open and ready, great. We can send it. If the serial port reference is bad, we're going to get an error out. You know, so here it's very simple. And again, if we were to highlight this code, right here, we could do this, and we could create a SubVI there. And maybe we would call this one check flag, so it checks to see if there's an error or if it's a message. And then here we might create a SubVI that just says pull out data. Again, I give all these meaningful names, and this might be right. This might output check alarm. Okay, and of course, you know, again, I would go save all these, give them a name, give them a nice icon, whether that's a text icon or not. And now, if you look at our code, it's a little bit clearer. So let's actually do that. Let's just go save this just so you can kind of see the full effect. So this is format command to read. And naming is hard. Why is that on demo? Let's put this to simple serial. So, do your best, but this is formatting the command to read. Format command to read. So we're going to manual range, channel all range. We're formatting the command to read. And then we're sending to the serial port. That makes sense. Let's do this. Save. Check flags. And if we give these names, so let's call this, one of these is error. The top one is valid measurement. This is valid measurement. And this is error. Check flags. And maybe I would bundle those together so you see an on bundle here, so it's a little bit easier to read. But so I did that. And of course, I would add a description here too that says a little bit about it. But and then here, right, this is extract data. We'll call it data array because it's an array of data. Click data array. And then here we have check alarm. And here you go. So that's some pretty simple refactoring that's got that cleaned up, and we can write tests for all these because all of these are pure VIs. If we have a string in, we can cover up with a couple examples, one where there's an error, one where there's not, one where maybe neither is true. We can come up with a couple examples for the command based on the various settings and make sure it comes out right. We can do all of that rather easily. And also it separates out all those concerns. So if you want to make a change to the way you're calculating the alarm, you don't have to change any of the other stuff. It's all in separate SubVI, so kind of separates the areas of concern. Before, if you want to make a change to that, you got to make a change to this giant VI with all this stuff going on, and it's possible that you accidentally change something or move something you didn't intend to. Now, if you're just down in that one VI, it's much less likely. Hopefully that helps.